d rho. Here we have got these two terminologies, plus what we are having, LDA. LDA is equal to minus, this is minus, this is also minus. So over here, if I want to place that particular value, over here, if I want to place this particular value, what I am going to get, I am having LDA is equal to minus 2 mu A dl, and here I am having rho LD dA. So what is LDA? LDA is equal to minus 2 mu LDA. So I am replacing this LDA in this particular place. So I will remove this one and I will try to minus. And here also I am having minus, means minus minus is going to become plus. So 2 mu rho, sorry, so here minus minus is going to become plus. I will first of all 2 mu, this rho we have taken as it is, then A dl. So here I have taken this particular terminology. So it is going to become plus, and here it is plus divided by this particular part, that is divided by A square. Okay, A square. Likewise, we have got this particular equation. Okay. So furthermore, your gauge factor has been defined. Your gauge factor has been defined as the ratio of, gauge factor is given as lambda. It is the ratio of change in resistance divided by change in the length of wire. Change in the length of wire, which can also be given as 1 plus 2 mu plus d rho by rho divided by dl by l. Only that change in resistivity. Rho is the resistivity of material, that I have replaced over there. So you can easily try to retrieve the information of the gauge factor that has been given as lambda. Now, 1 is the resistance change due to the change in length. Then 2 mu is the resistance change due to the area, and its range is 0 to 0.5 for all material. D rho by rho divided by dl by l is the resistance change due to the effect of piezoresistive effect. Now you have to take the note under consideration. Gauge factor should be high. It should be high. Why it should be high? So that it will be more change, or the change will be much more effective in the resistance, that can be utilized for the signal conditioning, and it will be the simple in the form. Okay, it will be simple in the form. Hence, in this case, dl by l is dominant increase of the semiconductor resistance is very high for the metal. So d rho by rho divided by dl by l is nothing but it is the product of pi, that is longitudinal piezoresistive coefficient, multiplied by Young's modulus E. Okay, so this pi, this particular pi, even can be considered as a positive, or it may also be negative one. You have to remember that particular thing. Okay. Strain gauge implementation. Now, how to implement a strain gauge? There are several methods for implementation of the strain gauge. What are that several methods? Unbounded metal wire gauge, bounded metal wire gauge, bounded metal foil gauge, bounded semiconductor gauge, diffuse semiconductor gauge. So these are the methods based upon which you people can implement the strain gauge for different application. Now, what is your application? Depending on your application, whatever may be the effective technique, you can utilize from all these mentioned techniques for implementation of that particular application. Okay, one by one we people will see. So strain gauge. Strain gauge comes in many forms and types. Any material combination of material or physical configuration that changes its resistance due to strain, due to strain constraints a strain gauge. We'll restrict our discussion to two types that accounts for the most of the strain gauges in day-to-day life application. And what are that two types of strain gauges commonly used in nowadays for the applications are wire or metal strain gauge, that is resistive type, and semiconductor strain gauge and semiconductor strain gauge. We will try to study thoroughly these two types. So metallic strain gauge, in this is the simplest form. Metallic strain gauge is the simplest form, a length of wire held between 2 points. So these are the 2 points, and over here between these 2 points this wire has been suspended, and if you apply force on this one, this will get stress or a strain, depending on which its resistance will increase or decrease. Okay, due to compression or elongation. Here we people are saying stress and strain. Stress and strain we people are saying for this particular aspect. Okay, so when force is applied to them, will deform the wire, causing change in the wire resistance. This method was used in a past and is valid one. Means this is implemented method, and it has been used in the application. But it is not a very practical one. Construction, then attachment to the system, change in resistance is very small. Because what happens, you cannot individually use the strain gauge. You have to use some platform to mount that particular strain gauge. Sometimes a multiple lengths of the wire were used in the previous application. If so, because why? The resistance change is very small, and we are interested to have large change in the resistance. To achieve that particular task, multiple length of the wires can be used. Okay, so this is the wire strain gauge. If you see over here, so these are nothing but these are the points or the position. Here we people are applying a force. This is nothing but the change in the length we people are getting. This is the diameter of the wire. This is the length, and after applying the force, this is the change in the length that has been achieved. This is the change in the length that has been achieved. Okay. So over here, you people are getting the wire. Actually, we people are interested in this particular wire having the change in the resistance due to change in the length of wire. And what is the cause of change in the length? The cause of change in the length is nothing but applied force. How much force you people are applying, depending on that, this change of the length is going to take place. And this change of the length will cause the change in resistance. Okay, so force is the mean of, actually we people can say force is directly proportional to resistance. We are not supposed to consider force is the